Hello, everyone, and thank you for joining our live session today. My name is Larissa, and I'm an event planner at Microsoft Reactor, joining you from São Paulo in Brazil. Before we start, I have some housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. The session is being recorded and will be available to view on demand here on the Reactor YouTube channel within 48 hours. Keep an eye on the chat. We'll be dropping helpful links and checking for questions for our presenter to answer at the end of the session. I will now turn it over to our speaker for today. Thank you and welcome, Johan.
Hello. Thank you very much for that, Larissa. I'm glad to be back with our second session on the Azure Developer Certification. These are only 1-hour sessions, and when we do the training for our customers and for Microsoft partners, for that matter, then a topic like Azure Functions could take 3-4 hours for us to cover. So these 1-hour sessions are short, but they should at least give you a high-level overview of what areas of the specific service you need to go and focus on specifically for the exam. Try to give you some exam tips. For the most part, you'll notice that you can get to the hands-on labs at that link there. Most of those course codes also work for our other links. So if you're, for example, doing the Azure DevOps course, AZ400 labs will take you through to the DevOps labs for that. So keep in mind that these course codes are short ways to get to our labs and content material like this. As per usual, I've got a repo called Course Content. In there, you will find a PowerShell folder. In the PowerShell folder, there's going to be AZ204 scripts. So most of the scripts and commands I'm going to be using today will be available in that repo. So you can go and fork or clone that repo to your heart's content. All right, so what's our agenda for today? We've only got an hour, so I'm going to try to go through as much as I can and see if I can give you as much demos as I can. We'll first start with an introduction to function apps. What are they? Why are they useful? How are they actually different from app services? Then we'll talk about the different plans. Of course, these different plans have different capabilities, also have different costs and different features. So we'll touch just briefly on that. And then as part of the learning path and the learning material, there's 2 or 3 tables in the learn material where they basically pivot functions against logic apps, against web jobs. So I've got one diagram for that. We will take a look at that as well. Expect some exam questions around that, I reckon. And then we will, once we've covered all the concepts, we will take a look at the tools and how to actually develop some of these functions and eventually how to deploy these. We'll conclude with a bit of a summary, and then you can get cracking in preparing for the exam. So, introducing Azure Functions. We're talking here about event-driven programming, and what I mean by that is, think about what we were talking about in the first week on this series. We're talking about app services, and of course, app services have are going to be HTTP based. For the most part, they're going to be HTTP based. Function apps are not necessarily HTTP based, but they can be. A function app is more about what code do you want to execute and when do you want to execute that code. So it's very important to understand that functions always have triggers. There's always some sort of a trigger, and the trigger could be something that's happened inside of Azure. It could be a timer trigger, like a cron schedule. It could also be a HTTP request that's just, arriving at the function app with a post, or just a GET request for that matter. So when we're talking about event-driven programming, this is more to do with events in Azure. And when I'm talking about events in Azure, most of our different services in Azure have got different events that it can expose, and those events can tie into an Azure function being triggered. I'll give you a quick example here. There you can see Azure notification hubs. This is like a type of mobile notification component we've got in Azure. If you're thinking of the event grid, if you're thinking of event hubs, Cosmos DB, right? The service bus. When a new message, when a new blob arrives in a storage account, I want to trigger the function. And on top of this, we've got a type of input-output binding capability that allows me to, with very simple programming or JSON semantics, provide a type of an input-output model that I don't have to program against. I'll give you an example of this in a few minutes. But here you can see I've got an Azure function in the middle. Oopsie. I've got an Azure function in the middle. And what might happen is when there's a new document on a Cosmos DB database, that might trigger my function. And that function might write some information out to a storage account. So I want you to keep in mind, when we're talking about functions, we're talking about triggers, and triggers are what starts or kicks off the function. But then we also have the concept of input-output bindings. So if you want to integrate into some of our Azure services, you don't have to go and write all that scaffolding code. It's really just, adornments that we are using to read and write information out. So this is a pretty old picture, but it's still relevant today, right? Functions integrate with almost all the prominent Azure services, and even with third-party services like Twilio and things like this. Now, it is important when you create one of these function apps, that you effectively select the right hosting plan. Keep in mind, though, that functions can also run as containers, and because functions can run as containers, you can be running functions in Kubernetes, Azure Container Instances. You can run them in Azure Container Apps for that matter, but we've got a specific function hosting plan capability in Azure, so you can bring your functions and run those functions in Azure. This is a list of all the hosting options and plans we've got. The relatively new one here is the Flex Consumption Plan. This is similar to our normal consumption plan, but you will see some additional enterprise capabilities. For example, VNet integration. If I was consuming this function app from a virtual machine on the Azure virtual networks, then I can link up this plan so that it's only accessible from that virtual network. Right, so some VNet integration. This is more in terms of where can I access this service from. And you can see the only one that doesn't have that is the consumption plan. The rest of them all have this capability. So Flex Consumption is a relatively new one on the block, and you will see also scales the best. Scales to 1,000 instances. Old consumption plan can only scale to 200 instances. No VNet integration. Also not dedicated compute, so shared compute in a way. And then you can also see the premium plan, which is kind of the most expensive plan of the lot for the most part. Most of our premium plans are the more pricey plans of the stack, and you can see this will scale to 100. You will also notice the app service plan, and if I've got an existing app service that are running app service web apps, then I can plug my function app onto one of those plans if it's not running containerized solutions. And then the last option here, interesting one, relatively new service, maybe about a year or two old in Azure now, Azure Container Apps. Azure Container Apps are effectively a managed Kubernetes cluster that you don't need to know all the semantics about Kubernetes to be able to manage these container apps. So we can run these in container apps as well. And there you've got loads of different options in terms of scale. And you can see that scales up to 300 replicas. So you get to choose the plan. And once you got the plan in place, you can start deploying your function apps. So what I'm planning to do here is I'm not actually going to create the function app, but I'll just show you some of these options. I'm going to go with a flex consumption. I don't think I've got one of these. I've got another one here, but it's running an app service plan. So I'm going to click on the create button. I'm going to go for flex consumption just because it's new, I guess. And then I'm going to create a new resource. I'm going to use one of my existing resource groups for my training today. And I'm going to go with Jazz, or let's just go with Reactor Function. I'm not going to go with that weird long name. You can see that I can specify my location, UK South. It's prompting me here for a runtime stack. You will notice that it's got PowerShell in there. This is not a finite list. We can actually, as long as you stick to specific folder structures, you can bring a lot more than what you see on the screen here. Strictly speaking, function apps can work with most frameworks and languages, if you think about it in that context, right? Of course, I'm going to go with .NET, being more or less a .NET developer my whole life. You will also see that I can go and specify the version of the .NET framework that I want to be using, and then you can see it's prompting me here for an instance size. Right, I can go with, say 248 megabytes or whatever that is. You'll notice that this is the amount of memory that's allocated to each instance. I think 502 should really cut the mustard. Zone redundancy, I've got this enabled. Of course, if I was choosing something like the basic consumption plan, this will not be enabled. Now, there is an interesting one here. You'll notice in the portal, of wherever for that matter, whenever you're creating a function app, we're also creating a storage account next to it. And the reason for this is, if you want to be running some long-running functions, anything to do with logging and things like this, we're going to be using that storage account. So function apps generally have a storage account, and we're using that storage account for some shared state if you were running something like durable functions, which give you some long-running function capabilities. So I will select, yes, I'm happy with a new storage account. You can see there that I can configure some of my diagnostic settings. I can also specify add Azure OpenAI and vector database, right? This is a brand new option as far as I'm aware. I'm not going to select that. And there you can see there's my networking options. So in other words, if I have a virtual network in Azure, and in that virtual network, I've got a subnet for my web servers. So there's a bunch of web servers in here. I don't want this function app of mine to be accessed from these web servers over the internet. That's just a bad idea. So what we do is we create a subnet here, call it the function subnet, and we configure our function app to have a network interface in that subnet. And now my web servers here can connect directly to my function app without ever having to leave the Azure backbone. All right, so there's some network integration here. You can also point it to a monitoring service, and with a monitoring service, we will essentially take some of your instrumentation and other telemetry, and we'll pump it through to an App Insights instance where you can go and do some further analysis around some of those services, some of those features and capabilities. From a deployment perspective, if you did want to do some continuous integration and continuous delivery, and your DevOps maturity is quite low, I guess, then you can configure deployment here, which will set up automated CI/CD pipeline with Azure DevOps or GitHub or one of a variety of different other services. So you can see there that I can go and change account if I wanted to, but I can also bring in some some other options if I wanted to. This, I'm driving it now from the function app, but if your DevOps maturity was high, you'll probably drive this from your GitHub Action side or from your Azure DevOps pipeline side for that matter. I'm not going to do deployment now, but you can also see there from an authentication perspective, you'll notice that what we recommend is that you use, these keys essentially to authenticate. And you can see there for host storage, there's my secrets, right? Or managed identity for that matter. So in other words, when I'm connecting to the storage account, am I going to use secrets from the storage account, or am I going to use a managed identity for that? So managed identity is basically almost like a type of service principal, if you like. And then you can see there's also the rest of these options. For development storage, we're going to use secrets. For app insights, we're also going to use secrets. So I'll click on the review and create button here. I'm not actually going to create it, but once I've created this function app, it's going to look like this. Right there you can see there's my function app called Never On. You will notice that I've already got a couple of functions in there, but there you can see there's most of the features we also spoke about with app services, right? You can see environment variables, that sort of thing. And these environment variables can literally be linked up with the key vault if you wanted to do something like that. All right, so once you select your plan, you know what capability and functionality you're going to be getting from that plan. Once you've selected your plan, you are now ready to start, building and deploying your functions in that function app of yours. Before we get to that, though, like I alluded to in the introduction, they might ask you questions in the exam of function apps versus logic apps versus web jobs. This is one dedicated, area in one of the learning paths in one of the modules. So you'll see if you go through the self-learn material, you'll notice that there's 5 or 6 different tables that compare some of these options. Now, I want to make it clear that functions is a code-first scenario, right? Logic apps is a designer first. So you're either going to use function apps, right, solving the problem with code, or you're going to build logic apps where you basically build your flow out in a logical flow scenario. I would actually prefer to show this to you quickly, just so you get an idea. I'm going to go type in the word logic apps here. Logic apps was also always a part of the course. It's not part of the course anymore, but there you can see my logic app designer I've got there. This is essentially an alert. And after that, I can go and add some actions. What do I want to do? I want to check to see if this is true, right? If that is true, then send an email, right? Do a batch operation, get the date time, right? Lots of different options. But you can see here, I'm not writing code. So logic apps is a designer first type approach. Web jobs that run in app services are also a code first approach. The connectivity functions has got some bindings to different services. Logic apps has got thousands of connectors. I can almost guarantee you, if we don't have integration into your service, man, I'll be quite impressed. I'll be really, really impressed, because this is like a massive list. I think there's something like 13 pages of connectors just starting with the letter A. All right. So in terms of integration with logic apps, that integration is already there. With function apps, you'll have to build that integration. Now, we do help you with some input and output bindings, but anything outside of the supported services, and you will have to scaffold that code together yourself. Web jobs don't have any bindings. Actions are code-based. And by the way, I can extend logic apps with additional functions. So if we've got some actions in logic apps, and you see, oh, I wish there was an action for this or for that, you can actually build that action using functions. So most of our logic app actions are actually functions in the background, but it's abstracted away in this graphical designer. So logic apps has got some pre-built actions. And in web jobs, all of this is also code-based. Monitoring, app insights for functions, logic apps going to be using the Azure Monitor. Web jobs are also going to be using the Azure Monitor. I don't think any of the web job components get pushed through to the app insights, even if your app service is connected to apps insights. And then just from a management perspective, how do you manage functions? Well, you can manage them via REST, via some of our developer tooling and IDEs, Visual Studio Code, but there's also a command line interface, which I'll demonstrate towards the end. And then it's obviously some other options as well. You were using, some other third-party IDEs and things like that. There's also a lot of support for these things, for function apps at least, in third-party tools for that matter. Logic apps, you're predominantly going to be building in the portal, but you can also use PowerShell and also Visual Studio and Visual Studio Code, because the logic app flow is a type of is really just actually a type of text document, right? That you can actually configure. And then the last thing here, you can see web jobs. You're also going to be using REST, or you're going to be using Visual Studio Code for some of these things. Execution, functions, cloud, as well as on-prem, but also in containers. Logic apps, cloud and on-prem as well. But web jobs is only cloud, only sits inside of app services. So I want to maybe just ensure here that you understand that whenever you look at our Learn material and you see a table like this, they love asking questions like this in the exam. You're hoping to design a first type solution for a customer of yours. What should you use? Function apps, logic apps, web jobs. Of course, that one is logic apps because it's the only one that's not got a code first type approach. Now, I alluded to triggers, input and output bindings. Every function that you create will have a very specific trigger. And you cannot get away from that. Without a trigger, a function actually doesn't exist. So when you create the function, however and whichever tool you are using to create a function, whenever you are doing that, you are specifying the trigger that's going to be triggering that function. Okay, so I'll give you a quick example here. I've got a little blank folder. It's called the function app. So this is a brand new folder. And well, let me rather just drain out the slides just quickly before we get to that. So I'm going to create the function app. I will add one or two functions to that function app. Each of those functions needs to have at least one trigger, right? It can actually only just have one trigger. So the trigger is what is going to create the instance of the function. And if it's a schedule trigger, it's going to be a cron job, cron schedule. If it's the HTTP trigger, there's going to be a HTTP post or a HTTP GET request that's going to end up, on the function. And it'll have a URL for that, of course. And then, based on the type of trigger that we've got, some of these triggers might actually provide an input to the function, if those some triggers are not inputs. I'll give you a quick example here. If I go to Azure Function, input, output, trigger, I might have made a couple of typos there. Triggers and bindings with Azure Functions. Just going to scroll down, and you'll see that there is a list of all the supported bindings. I basically just did a search for triggers, bindings, Azure Functions. That's the title of the item as well. And then you will see this is a list of all the options we've got. You can see there, blob storage. It's a trigger. It also provides input into the function. It can also provide an output. So we can output something to blob storage. Okay. Cosmos DB, all of those options. Data Explorer, it's an input, it's an output, it's not a trigger. Azure SQL, all of the above. Dapper integration, all of the above. Event Grid, it's a trigger, doesn't provide input, but it can also be an output. So you want to carefully go and look at some of these options. You can see there's Kafka, for example. Kafka can be a trigger, cannot be an input, can be an output. Mobile applications can be an input, cannot be an output, cannot be a trigger. So you have to go and make sure you understand which of these options you're going to be using and how you're planning to trigger and augment the function with some additional data. So if I go back to this slide here, you'll notice that possibly what we want to do is we want to check to see what data is in Cosmos DB, and then we want to remove the data from Cosmos DB and push it into blob storage or push it into event hubs, or both for that matter. So what I do is I create a function. I create this function on a schedule. And then in my function code, I basically specify I'm going to have an input. Oopsie. Can you believe that? So because a schedule trigger is not an input, what I'm going to do is every 5 minutes, because this might be a 5-minute trigger, I might say every 5 minutes, this function is going to trigger itself with that timer. It's going to run a query on Cosmos DB, bring back some Cosmos DB documents, and then it's going to write out these documents into Azure storage, but it's also going to write out some of that content onto event hubs. So in Azure Functions, we've got this concept of triggers, always required, but we've also got the concept of input and output bindings. So you can think of this as, the ability for me to say, well, here's the data, it's coming through my function, I'm going to drop a copy here. Right, and you can use that for those lambda patterns where you've got some hot storage, cold storage, however you want to slice and dice this information. All right, so what I'm going to do here is I'm going to quickly give you a quick example of code that does this. I'm going to head over to my func. This is just a repo that I've got. And if I look at my source code here, you can see I've got a function here, and this function specifically has got, it's called process sales order. This is the one I've got in my never on function app, and you can see there it's got some outputs, and all I needed to do is specify table output as an adornment on my method. I specify the name of the table, and I specify the database connection string that I'm going to be using in my environmental variables. And then you can see I can say sales order entity queue trigger. So in other words, somewhere there's an Azure storage queue, and as messages arrive in this storage queue, every time there's a message arriving in the queue, we're going to trigger our function, and our function is going to write this information over into Azure tables. So you can see there, the queue trigger and a queue provides both a trigger as well as an input. So I can really just take that queue message. There's the queue message. And you can see I'm creating a new sales order entity. The sales order entity is actually just this one over here, nothing too fancy. So I'm going to go for my sales order function, and you can see there, that is list, not process. And all I'm doing there is I'm specifying table output, and I'm populating that object, the sales order entity. And based on this, it's going to write this information out to that table. Every time there's something on the queue in sales orders, it's going to clear out the queue and write this information out to a table. Let me see if I can demonstrate that for you quickly. So there's a function app that I've got now. I've already created it earlier. You should see that I've got a function there called process sales order. And in here, if I look at my invocations at least, you will see that there's a couple of invocations. So how do we bump that up and show some more? I'm going to go to portal.azure.com and just go to the root there. There's my storage account called Never On. And if I go to my data browser, my storage browser here, then you can see that there's my tables, sales order table. I'm going to delete all of these items from the sales order table quickly, just so you can see it's clear. Then I'm going to head over to queues here, and I've got my sales order queue. Just pop a message on there. The message, hit the OK button. I'm just going to refresh a few times here. There we go, message is gone. If I go to my sales order table, there's the message. So what's happened here? I created a function based on a storage queue, and all I did was, I just returned one of these sales order entities, and whatever was returned by this function will get written out to that table. So I did all of that integration without creating a storage client, without creating a storage table client or a storage queue client, anything like that. I didn't have to create any code for that. All right. These semantics really just work. So for .NET and Java, you can adorn your functions like this. For anything else, like Node.js, for example, you will notice that there's actually a function JSON file. So there's a config file per function app that I essentially configure the triggers, the input, and the output bindings. I've got an example of that. So if I've created and published my function app, now the function app is living inside of Azure, how do I start developing solutions for this? And that's pretty much what we're going to be talking about next year. We just check the time. The next thing here is, how do I develop these functions? What tools do we have available? Now, of course, folks, for the exam, you're going to have to dig a little bit deeper than me and my 45 minutes on functions, right? There's a lot more than we can cover in 1 hour. So just make sure you go through the content. So when you're developing functions, there's generally going to be two files that you'll always see. There's always a host.json file. This is metadata for all the functions. And then there's also a local settings.json file. This is generally used if I'm using some of the developer tools locally. It uses that local settings.json file. Each function is also going to have a function.json file that identifies input output bindings and the different triggers for the file. You can see there's an example of one of these files. All right, where I basically specify the queue trigger, and you can see that there's a table binding. This is an output binding. Oops, daisies. This is a out binding, right? So that means after this function is done, it would have written to the person table, and it would have written, whatever was in that queue message onto that table. And then depending on the tools you are using, of course, Visual Studio Code has got some great integration. Visual Studio has got some good integration, project types that you can create and configure. The one I want to demonstrate for you, though, is this one over here, and you might get some questions in the exam on this. Function Core Tools. This is a program that you can essentially download, very similar to the .NET SDK tools, right? Where you run the commands locally, and you'll see that there's a variety of different options around that. So what I'm going to do here is I'm in my blank folder. You'll see there's nothing in here currently. If I just do an ls, it's completely empty. So what I'm going to do is I'm going to go func init. This will initialize the function project for me, and you can see that I can choose between a variety of different options. .NET isolated, .NET in process, Node, etc. I'm going to go with .NET isolated worker model. I'm going to choose C# as my programming language. And then you'll notice it goes and scaffolds out this entire folder and project structure for me. There you can see there's local settings.json. It's actually using and defaulting to development storage locally. What I'll typically do is I'll typically replace that with a connection string to a storage account, and then it'll use that Azure Web Job storage, for its long-running state. But there you can see there's, host.json as well, and you can see that this, sort of alludes to using app insights, some sampling settings, etc. There is a program.cs file here, but you'll see this program file basically is very, very limited. So if you needed to work with some dependency injection or establish all sorts of different components, you can actually do that in program.cs. Very similar to what you might do with one of our ASP.NET applications. Okay, so I've got the function project now, but for the next part, what I want to do is I actually want to add a function into the function app. So func new is going to prompt me for the type of trigger. Now this is critical because you'll see there it says Q trigger, HTTP trigger, blob trigger. I cannot create the function if the function doesn't know how it's going to be running. As simple as that. Right? In this case, we might go for something like a timer trigger. Just show you a timer trigger. Function name, timer func. It'll create a .NET function, and you'll see within a second, there's my timer function, and you will actually see that cron schedule there. There we go. This function is going to be running on a timer trigger, and it's going to be running every 5 minutes. Okay. I can actually also use this function command line tools to do this func start, and this will effectively start an instance of the function runtime, and it will essentially allow me to test some of these functions locally without me having to deploy first to something like Azure or something like this. And you will see that it should actually pick up that there's at least one function. Hello? That there's at least one function. It's exited with a specific code there. Exceeded language worker restart count. Interesting. Thank you very much for that. I'm going to just shut that down quickly. It's not shutting down. All right, I'll just completely trash it. That should also work. All right, so I mentioned the function core tools. I mentioned func init, which will initialize a new project structure, func new, and then also, you can see if I wanted to publish, I can run the that's not fun actually. Apologies for that. Func new, and then lastly, func Azure function app publish and the app name. So I'm going to see if I can just pull something like that through here. I'm going to go back to my code, start up a new terminal, and in this case, I'm going to go with func new. This time, I'm going to use a HTTP trigger, function name, get data, something very, very simple. It's creating the function, and you should see the get data function over here now. And there you can see function HTTP trigger, and to this end you'll see the authorization level is function level. This could be something like anonymous as well. So I can make this anonymously, and you can also see that I can specify the HTTP methods I want to be using for this. So in this case, it's going to accept both get and post requests. And then further to this, it's effectively telling me, welcome, You've logged on to Azure Functions, and in actual fact, I should be able to specify something like a, a string username there, and then further to this, I can go and specify something like, log information, username, and then return okay, welcome to. And then, of course, what I'm planning to do here is just something like a, what's it, dollar and functions username. Something relatively simple like that. This is probably not the best of ideas here because I'm not checking for blanks and things like this. However, it'll prove the point. I'm going to delete this little timer function because that might have messed up a couple of things on my behalf here. So what I'm going to do is I'm just quickly going to do a .NET build and check if .NET is happy. And then I'll start up this function app using that function core tools. Build succeeded, so func start. See if that works. Very interesting that it's actually not running here locally. Find that a bit strange. Anyways, I'm not gonna worry about that too much. It's obviously something weird going on here on my device or something. I'm not going to be too concerned. But what I do want to show you quickly is if I just pop back in here. Wonder if that is not the case. I don't have .NET 8 on here. I've only got .NET 9 on here. Hello. That's all I needed, right? It was targeting .NET 8. I've only got .NET 9 on here. So, no surprises there really. All right, but there you can see get data. And that should have propped open a get data option, right? And I should be able to say something like username equals to Joe. And you can see the hello, welcome to Azure Functions, Joe. Right? Very, very straightforward. Now, what I want to do is I want to just mention a few things. In the exam, they will not ask questions about durable functions. They've removed durable functions from the course. I'm not sure why. For me, durable functions are really a big part of using Azure Functions. The reason why I say that is based on some of the plans you select, there's a limit to the amount of time these functions can run for. So we're really referring here more to a type of a microservices architecture. And with microservices, you're trying to get short-running stateless code, right? And to that end, if that's your overall design goal, Azure Functions is perfect for that. But if you find that you run into some of those limitations, you can always enable something called durable functions. And with durable functions, we've got some orchestration and stateful functions that allows me to manage, 5 or 6 daisy-chained functions and keep that orchestration sort of in line, right? So there's lots of other options around functions, but for the exam, you just need to understand at a high level what functions are, and then, on different ways to develop this. You will see, however, as part of the course material, there's bound to be, some deep dive items where they go into specific areas like, hey, why is my function app always very, very slow to start? Maybe you're using the consumption plan. This consumption plan scales to 0, right? So how do I remedy that? I change the plan. There's always the instance waiting for my plan to execute the code. All right, so There you can also see an example of some of these. I've shown you some examples of C# code with those input and output bindings. I've really gone through these items quite quickly, folks. So in conclusion, before I take some questions, why Azure Functions? Well, generally, app services tend to be monolith, sort of hierarchical type applications, big applications that if I update an operation, I take the whole app down. With functions, we're hoping for more of a granular type approach. We've also got different triggers, not just HTTP triggers. We've got a very simple semantic for input and output bindings. And then we've also got some great Azure integration. And you can see that Azure integration from here, basically, right? We just shut this down. Or then not. Just create another one quickly. So if I go func new, you can see we've got great integrations in all of these. Storage queues, blobs, event grid, timer, that's fine, event hub. This is basically a Microsoft Kafka implementation, right? So you want some big data aggregation, the ability to do windowed queries and overlapping windowed queries like that. We can also link it up with a service bus. All of these are different types of triggers, but most of these are also input and output bindings. So for the most part in Azure, our functions have got really, really solid and simple integration with most of our other services. There you can see Cosmos DB, Event Grid, and then a variety of other Dapper type functions. And that, ladies and gents, is pretty much that. I spoke about the Azure integration component. We spoke a little bit about the scale as well. And then lastly, just some of the key concepts that I want to make sure you're on top of as far as the exam is concerned. Make sure you understand the differences between the different types of plans, which of them scale down to 0, which of them have VNet integration for that matter. In the exam, they will ask you questions about that, and sometimes that information is not easy to get a hold of in the exam because you've only got access to Microsoft Learn Search, right? So learn how to use Microsoft Learn Search. That's one of my other recommendations. Other concepts, make sure you understand what triggers are, and also make sure you understand that there's a difference between a trigger and an input and output binding. Sometimes a trigger can also be an input, but think of a simple example like a function that runs on a schedule. That schedule is just a timer. So a schedule trigger definitely does not provide an input binding, if that makes sense. Other than that, there's a pretty good lab that's part of the labs that I shared with you at the beginning. You are welcome to go and do those labs at your own time. Make sure you've at least worked through those labs at least once, I would say. And then this is one of those areas where practical experience might help you a lot. If you're new to functions, get some practical hands-on experience there before you actually go and hit that exam. All right, it's not a long session like our app server sessions. For the first 4 sessions we'll be doing, the second and the 4th session, Cosmos DB coming in a few weeks, are also quite relatively short. Okay, so that's a quick summary of Azure Functions. I hope that's provided you with at least a high-level overview of the service and how to develop solutions around this and what it's useful for. Let's see if there are any questions.
Hey, yeah, we've got a couple of questions here. So the first question is from Wesley. He asked, does Logic Apps create code after creating the flow you showed?
I wouldn't say it creates code, but even if it did create code, it's abstracted away from you. You will never have access to that. So no, I don't think it's a question of it creates code, but it does scaffold together something that can execute your code, right? Remember what I said, Logic Apps are effectively functions with a logical workflow designer on top of them. So actually, each of those actions is code. It's just the orchestrator and the graphical designer orchestrates all of that. Wesley, I hope that answers your question. So actually, if I'm using logic apps, each of those actions, send mail, it is actually a function that's executing. So I would not say it generates code, but it does orchestrate for existing code to be called, if that answers your question. So I was hoping there for a second I'll see Wesley nod his head, but then I realized it was just a picture of him.
Okay, the next question was from Benki. I hope I'm saying your name right. What about management? Logic apps by using Azure CLI?
Yeah, we do have CLI and PowerShell integration, but we're talking more about the management in terms of building a solution, not the administration part. So yeah, absolutely, you'll be able to use CLI and PowerShell for those to manage logic apps as well as function apps. Most of what you can do through the portal, you can also do through Azure CLI and through Azure PowerShell. I hope that answered that question as well.
Okay, then another question from Wesley. Depending on the trigger I select, can I receive a different charge?
No, the costing is not associated with the trigger. The costing is associated with your function and how long your function runs for. So the trigger is irrelevant, right? But into that same token, if I, for example, had a trigger of the service bus, of course, the service bus has got a cost separate from functions. But no, and as far as I'm aware, we don't charge you differently if the function was triggered with HTTP or if the function was triggered with a schedule or a blob added to a storage account for that matter. I hope that makes sense. I think it's also Wesley.
And then the last of Wesley's questions was, so a function app could work as a consumer worker, right?
Let me just read that question. Where is that also, Wesley? So a function app could work as a consumer worker. I'm not sure what you mean as a consumer worker. Is that because I flagged it as anonymous and I can now anonymously call it? Maybe that's what you're referring to. Function apps can provide the backend API for anything. Applications that need to authenticate securely, so I can specify a key. Applications that need to authenticate anonymously and send HTTP data. So yeah, totally. In actual fact, if you're interested in that, you will see we've got a service called Azure Static Web Apps that gives you a static web app front end and an Azure Function backend, right? So in that context, because they all sit under the same URL, there's no cross-site scripting and things like that involved. But yeah, absolutely. If I wanted to, I can have an anonymous function and I can have people sitting in their web browsers, and when they click a button, it sends a request anonymously to an Azure function and returns some data that the user might want to see. So yeah, absolutely.
I'll skip Mr. Programmer's question and go to Nazik's question. So we answer Mr. Programmer's question as the last one because it could be a question for other people as well. So Nazik asks, can I run one or more functions locally for debugging?
Can I? Well, let me just read that. I just want to see where that is.
I'll pop it on the screen.
There we go. The blue one. Can I run one or more functions locally for debugging? Absolutely, Nazik. That's exactly what I did here, right? There we go. Running the function locally. So yeah, absolutely, that's possible. I can debug it properly now. I can use, developer storage so it looks and smells like there's storage involved. So yeah, absolutely, that's exactly what I'm doing. In order to do that, you will use these function core tools that I've spoken about. So I hope that answers that question as well. Uh,
Okay. How can we authenticate requests on function?
what a nice question. So, because where's my get data? So in this instance here, what I've specified is anonymous, right? But you can see I can also have a lot of other options: user, admin, system. And if I go through to my function app in Azure here, and I go and, where's my function app? There's the function app. You can see there's something called function keys, right? So I can essentially, if this was a function that was triggered with an HTTP request, I can make that completely anonymous if I wanted to do that. But if not, I can generate a new function key here, give it a name, give it a proper value, and hit the add button. And then I can actually use this value to call the key, to call the function. So you use these types of keys to do this, if that makes sense. And in actual fact, if I scroll down, you will see that under my functions section there's app keys, and you will see that there's one master key to rule them all. And there's also a default key here, but I can also add some additional host keys. So a host key will essentially give you access to most of all the functions on that host. So yeah, I hope that answers the question. You will secure these, especially the HTTP ones, because that's the ones that you're requesting a request from, right? But if I was triggering it from something like blob storage, there's no security involved there, if that makes sense.
Okay, our last question was from Mr. Programmer. I'll pop it on the screen as well because it's nice to have it on recorded. He asked, what text-based /videos /YouTube playlists, resources, or study guides should I use to prepare effectively for Developer Associate?
Yeah, that's a good question. If I do a search here for AZ204, you will see that there's this is the course. Of course, I'm not sure if you were not with us last week, but if you just do a search for AZ204, you will see that there is all the material, right? So if I click through on App Service Web Apps, let's rather go for Function Apps because that we spoke about today. You can see there is all the material. There's even some module assessments towards the bottom there. If I compare the different function hosting options, you'll see all of this is in there. So we've got course material for all of our courses are in there. And then, of course, you can also search for, if you do a search, I think, for MTT YouTube channel, but gosh, folks, there you can see there's the MTT channel. Let's just reject all of these options. This is essentially, oopsie. This is some. That's not the right one. we've got another. There is a MTT channel where we basically have got some MTT technical trainers from Microsoft that are publishing some videos in there, but definitely I would think of videos from John Saville, for example. Also, if you go to the actual course, right, you will see right at the top, you can see self-directed training. That's basically the training at the bottom there. You can also see towards the right at the bottom here, or if I go to the exam, I think there's the Developer Associate. Then you will see prepare for the exam, practice for the exam, right? There's some practice tests that you can take. Now, I've got some stats around this. If you've passed this practice test twice, you're probably going to pass the exam. So that's a good starting point. You can also see that there's some hands-on demos. So I guess the short answer here, Mr. Programmer, is go to the course page and you'll see there's lots of options. There's exam prep videos. I can go and watch these videos, right? So there's loads of resources available just for you to go and check out. I hope that answers that question. I also see that there was a last question about, I was talking about consume messages from RabbitMQ or Kafka. Yeah, you can use those, Wesley, as triggers, but just be aware of the fact that the message from a RabbitMQ or from Kafka might not be an input. All right, so it might be able to trigger your function. I don't think those count as inputs. So that's something that you'll have to go and check out. All right. Other than that, folks, I hope I've answered all the questions. But of course, if you are always welcome to head over to this URL, akka.ms/Johan. This is my LinkedIn profile. So if you do have any further questions, I might not get to you immediately, but I'm happy to field some questions on LinkedIn if you do have some. Okay. Other than that, I hope that you guys learned a lot. Thanks a lot from my side. It's been nice spending some time with you, and good luck studying for your exam. Thank you very much.
Thank you, Johan. See you next week. And thank you, everyone, for joining us today. Just a reminder that all the sessions resources are being sent to our thank you email after the session is over. So don't forget to register so you get them on your email as well. And thank you all for joining, and thank you for taking your time to learn with us today. We are always looking to improve our sessions and your experience. So if you have any feedback for us, we would love to hear it. You can find the link on the screen or in the chat, and we'll see you on the next one.